Alright, so we're going to learn how to do this in the lesson, but I want to talk about how you would just do it if you didn't know the math behind it. So let's take the word tap. And if we're going to rearrange this, we have taps, so there's one. Keeping T in the first place, we would have TPA. Now let's put A in front, so we have APT, and then ATP. Now let's put the P in front. We have PAT and PTA. So that's a total of 6. Okay. Now in number 2, we're not going to do 3 and 4. We'll talk about that later. In number 2, notice how we have pop. And if I switch places with these two, I'd still have pop. But let's talk about that. Let's label this 1 and label this 2. So I can have pop. And I can have P1, P2, O. Now I'm going to move the O to the front. And I can have P1, P2, whoops, and P2, P1. And if I move P2 to the front, I could have this, and I could have this. So initially you would say, well, just like number 1, there's 6 possibilities. But we have POP twice. In real life, those are the same words. So we would cross this one out. And then we have 2 of those, and we have 2 of those. So we actually only end up with 3. And we'll talk about in this unit mathematically why and how to do this faster without having to draw it out. We're going to use that counting principle we talked about earlier. Okay, now we're not actually going to work with a partner on this, obviously, but let's just go through this problem. The tree diagram shows all the outcomes of flipping a coin twice, or 2 coins, whatever, and then spinning a spinner. So, you have heads or tails. After heads, you have heads or tails again. After tails, you have heads or tails. And then you can get 1 through 3 each time. So how many possible outcomes are there? Well, 3, 6, 9, 12. And list the possible outcomes. Okay, that's again where we use our famous braces. And we just follow along. H, H1. And then H, H2. And then H, H3. All right. Then we go HT1. And we're going to go HT2 and HT3. Then we're going to start with tails. I'm going to come down here. TH1. And then TH2. And TH3. And then it would be tails, tails. So tails, tails 1, tails, tails 2, tails, tails 3. And those are our 12 possibilities. 6 with heads first and 6 with tails first. Sorry, the board's a little bit off. Okay, permutation. Fancy math word. It's the arrangement of objects in which order is important. This is very key here. Order is important with permutations. For instance, the 6 possible permutations of the letters A, B, C are shown. Okay, it's kind of like what we just did with our first letter tap. Okay, 6 possibilities. Okay. Okay, example 1. Consider the number of permutations in the letter of the words July. How many ways can you arrange all of the letters and 2 of the letters? Okay, so here's where we get to saving some time. Instead of doing the writing it out, we're going to use the dash method we talked about, okay, the fundamental counting principle. So we have 4 letters. Well, how many letters can go in the first spot? 4. Well, if that letter's taken, there's only 3 left here, 2 left here, and 1 left here. We multiply, and we get 24 possible outcomes. Okay? Now, for part B, it says you only want 2 of the letters. Well, You have 4 choices here, 3 choices here, that's it. Multiply, 12 possible outcomes. Sorry, word is really being a pain. Okay, permutations. Here is the actual formula, mathematical formula for permutation. Let me reset the board. All right, so now we have a new concept here, and it's this exclamation point. This exclamation point has the word factorial attached to it. So when we see an exclamation point, we say factorial. And now I'm going to explain to you what it means. So it makes a little more sense if we come over here. What we just did was the fundamental counting principle, but it works out the same way. If we have 4 people standing up for a photo, 1 person, all 4 people can stand there. But then only 3 here, 2 here, and 1 here. We've talked about this many times. Well, this is the same thing as 4 factorial. It means take 4 times 3 times 2 times 1. So 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1, and so forth. That's all it means. So when we're just arranging 4 objects, and they all have a certain place to be, it's the same thing as saying 4 factorial. Now, if we have a certain number of people or objects, but we're only taking a certain number, like let's say 15 people are trying out for a team, but only 12 are being picked, or 10 people are trying to go for a job and they're going to be picked in teams of 2. That's where we get down here to this formula. Okay? So the number of permutations of 4 objects taken 2 at a time. The formula says on top we have 4 factorial, and in the bottom we do 4 minus 2 factorial. And these cancel. Now, I'm also going to show you a nice way with the calculator that you can use, if I can get the calculator to work. So here's what you're going to do on your calculator. You're going to go to the math key and see up here where it says PRB, that stands for probability. You're just going to arrow over to that. You could go right 3 times, but less faster. See number 2, how it says NPR? You just click 2. Okay? Now, that's not how you do it mathematically. I just want to show you where it is. So, let's say we're doing the same problem with 4 items chosen 2 at a time. Boom. 12. Same answer as right there. And we'll practice this. Okay? Moving on. So, 10 horses are running a race. How many different ways can the horses finish first, second, and third? Alright? So, that is going to be, again, a permutation. And it's 10 items with 3 chosen. So, mathematically, we would put that, 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. And you could actually do this, okay? Let me show you how that works. If you wanted to do it this way, this is the longer way, but you're going to have to know how to do factorials anyway. So you can just hit 10, go to that math key, and look at number 4, factorial. And then hit divide by 3, math, factorial. Whoops, I was supposed to put 7 factorial. Silly me. Let's try that again. 10, math, factorial. Well, I hit equals, but same thing. Divided by 7, math, factorial. There it is, 720. But let's see the faster way. If I just say 10, math, go down to NPR for permutation, and put 3, 720. Same thing. So there's 720 possibilities. Okay? You get a lot of practice with the calculator on this. Okay, for a town parade, you will ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first, and the float with the school chorus is second. Okay, so this one's a little bit challenging, but it'll make sense, hopefully, once we go through it. So first off, there's 12 floats, and they're in random order. So that means 12 factorial, which remember is the same thing as this. All right. Now, that is all possible outcomes. Okay, 12 factorial. Okay, then we're talking about what we want to happen. So if we want first and second, all right, then that means there's 10 spots left, which is going to be 10 factorial. So what we want to do is we want the probability of soccer first and chorus second. All right. Well, that means we're going to have a ratio of 10 factorial over 12 factorial. All right. So if we type that into our, that's not what I wanted. If we type that in our calculator, we have 10. Remember, go to math, go over here and hit 4, and we're just going to say divided by 12 math. And the more you do this, the more you get used to it. 12, and there's our answer. Now, that doesn't really help as much, so I'm going to turn it into a fraction. Here's how you do that. See the math key? This just says, give me my answer as a fraction. Very nice feature. There you go, 1 over 132. Now, here's another easy way of doing that. If you didn't have a calculator, this is 10 factorial, and 12 factorial is 12 times 11 times 10. That's just 12 times 11 times 10 factorial. That cancels, leaving you 1 over 12 times 11, which is 132. Okay. Now, combination is where order is not important. Okay? So if you're drawing for 3 identical prizes, it doesn't matter which one you get. Order doesn't matter at all. Permutations does. That'd be like first, second, third prize. Okay, count the possible combinations of 2 letters chosen from the list A, B, C, D. Now, if we wrote these out, all the possible choices, we would get A followed by B, we get A followed by C, and we get A followed by D. Then going B first, we'd have BA, BC, BD. CA, CB, CD. And then DA, DB, and DC. But if order doesn't matter, we don't want the repeats. And see, we have AC and CA. We have DB and BD. We have DA and AD. I said that backwards. DC and CD. BC and CB. And BA and AB. So those are all repeats. So even though there's 12 possibilities, half of them are double. So that gives me 6. But if I did not want to do the drawing out of that, I have 4 letters to choose from, and I'm picking 2 letters, but since order doesn't matter, I'm doing a combination. So watch what happens. If I go to my handy dandy calculator and hit 4, math, PRB, now this time I hit 3, and then 2, and there's my answer. 6 possibilities. So that's what we just did. I just kind of previewed that. Okay? Okay, you order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Okay? So again, when you look at this, you have 8 choices. You're picking 2. Order doesn't matter. Green beans and mashed potatoes is the same thing as mashed potatoes and green beans. So, again, let's go to our calculator. 8. Shoot. Math. Go over to PRB. And CR, this is a combination, 2. And there's my answer. 28 different possibilities. Okay, your book editor has selected 14 photos, including one of you and your friend to use in collage. The photos are placed at random. There's room for 2 photos at the top. What's probably your photo and your friend's photo are the 2 placed at the top of the page. So this is going to be similar to the parade problem. We have 14 photos. We're picking 2, okay, and we're doing a combination. So we do 14, 2, again, 14, math, PRB, 3, 2. That gives us 91 possible outcomes. So that's not what the question is. The question is, what's the probability that your photo and your friend's photo are the 2 placed at the top of the page? So that's one situation out of the possible 91 outcomes, which is not very likely, but that's your chance. Okay, now I want to come back to the idea before we had with POP. Okay? So with POP, we wrote out and saw how to do the possibilities. But I want to show how to do it with the calculator. Okay, so first off, if we just did this, we would say it's going to be, 3 times 2 times 1, 6. And there were 6 possibilities. But if we want to get rid of the repeats, okay, and remember, this is 3 factorial. What we have to do is we have to divide by the numbers, or the letters repeating, how many there are, factorial. So since there's 2 p's, we need to do that. So 3 factorial is 6, 2 times 1 is 2, and that leads to the 3 that we had earlier. So let's go to the word we had before, noon. That's no. Okay. Well, with noon, we have 4 factorial on the top, right? But we have 2 n's and 2 o's. So on the top, we have 4 times 3 times 2 times 1, which is 24. And at the bottom, 2 times 1 and 2 times 1. So that means there's only 6 possible outcomes. Okay? Let's try one more real quickly, just for practice to look back at. The word pepper. Okay? Well, we have 1, 2, 3, 4, 5, 6. So that's 6 factorial. But we have how many p's? We have 3 p's repeated, and we have 2 e's repeated. Okay? So let's use our calculator on this one. We have 6 math factorial, and we can get that answer if we want, or we can just divide by, and we have to put in parentheses, 3 math factorial times 2 math factorial. And we get 60 possible outcomes.